Hello, welcome back to the channel. So let's continue our previous videos and do one last question on calculations of integrals of trigonometric functions in this case. So in this question, we have to calculate the integral of x sine x cos x dx. And again, we see the same pattern that we saw in the previous videos. Since we have a combination of sine and cos function together, it gives us an idea that since we know that sine 2x is 2 sine x cos x, so we can easily convert this sine x cos x expression into the sine 2x expression over here, right? So that is the first thing that we can do in order to simplify our original indefinite integral over here, and then simply reduce this 3 function integral into a 2 function one, right? Because if we convert or reduce our x sine x cos x expression to just x sine 2x expression, we will have 2 functions, and as soon as we'll have 2 functions, we can easily use integration by parts in order to solve for indefinite integrals which include 2 functions, right? So let's first write the sine 2x formula over here. We know that sine 2x is basically 2 sine x cos x over here. And there is also one more important point. Since we are using the sine 2x approach over here, it isn't like this is the only approach to solve this question. There are indeed multiple approaches in order to solve this question. And we'll also talk about the different approaches at the end. But if we use this approach over here, this would be the easiest one to follow in this case over here. So now since we have written the sine 2x formula and we know we are only concerned with converting sine x cos x term, so we know from this formula that sine x cos x is basically sine 2x upon 2, right? If we can bring this to the denominator, our sine x cos x is basically sine 2x by 2, right? So we can write our original integral expression as simply x sine 2x upon 2 in this case, right? And then we'll have a dx component as well, right? So now we have to solve for the integral of x sine 2x by 2 dx in this case. And again, since we see a combination of 2 functions over here, which is x and sine 2x, it gives us an idea that this integral will be easier to solve using integration by parts over here, right? So again, we have already solved the integral of these type of expressions where we had a polynomial function and a trigonometric function or an exponential function, right? So we know that when we have these type of questions, when we have one function as the polynomial function and the second function as a trigonometric or an exponential function, we always, when we are dealing with integration by parts, we always assume our first function to be the polynomial function and the second function to be the trigonometric function in this case. So the trigonometric function in this case is simply sine 2x by 2. Don't worry about the constant, you can include the constant in x by 2 term as well, whatever seems the most simple to you. So if you have to do it the other way around, you can also assume your fx to be x by 2 and your gx to be simply sine 2x in this case. It won't really matter a lot because the final answer would not change if you take the constant over here or even over here. You can also take the constant out in this case and solve for simply the integral of x sine 2x dx, and then whatever answer you'll get at the end, you can divide it by 2 to get your final answer over here. So now again, since we are taking this approach over here, let's calculate the integral using integration by parts over here. So we know the formula for integration by parts, which is first function as it is, integration of second. So integration of second minus differentiation of first is 1, integration of second, so integration of this expression, and then the integration of the whole second expression over here, right? So we have used the exact formula of integration by parts, which we already covered in the last videos. So if you have not watched my previous videos on integration by parts, I would highly suggest you to first watch my previous videos on integration by parts, which you can also see on the I button above, in order to get the full idea about what we did in this expression over here. So now let's solve this expression over here, but before solving the expression over here, let's first calculate the integral of sine 2x by 2 in this case. So now in order to solve for this integral, we have already solved this integral in the previous videos as well. You can basically assume your u function to be 2x, and then if you assume your u function to be 2x, your du would be 2 dx, and then you can make those modifications in this original indefinite integral and solve for the integral of this expression. But the answer you'll get at the end would basically be minus cos 2x by 4 plus the constant of integration in this case. Again, we solved this using substitution, or if you know the approach on how to solve these type of integrals when you have a constant attached to your x function, you simply have to take the general integral of this expression. Since you know that the integral of sine function is a minus cos function, so you will write this integral of sine 2x as minus cos 2x, and then whatever constant is attached to your x expression, you'll always take the reciprocal of that constant, which in this case is 1 by 2, and then you'll attach it to the answer. So that is why when we solved for the integral of sine 2x over here, we got minus 2x upon 2, and since we already had a 2 in the denominator, we multiplied it with the 2 that we had for this integral expression over here. Don't worry if that seems complicated. You can always use substitution and assume your u function to be 2x in order to solve for this integral over here. And I would highly suggest you to first solve for this indefinite integral before we calculate the answer to this expression over here. So now we know the integral for the sine 2x by 2 expression, which is minus cos 2x by 4 plus the constant of integration if you're calculating just the indefinite integral. And now let's substitute all the values in this function over here. So the answer would be, let's move this expression down. So this is the expression that we have to solve again. And the answer to this expression is basically, since we know that the integral of sine 2x by 2 is basically minus cos 2x by 4. And then this expression over here will be simply converted to minus cos 2x by 4 and then dx over here, right? And this was originally sine 2x by 2 over here, right? So now let's further simplify this expression over here. The expression would be minus x cos 2x by 4 plus integral cos 2x by 4 dx in this case. And again, the same way to solve this integral over here. You can again use substitution to solve this integral. And if you'll solve this integral over here, you'll get your final answer to be minus x cos 2x by 4 will remain the same. And then this expression over here, since you know that the integral of a cos function is the sine function, so it would be sine 2x. And then since you have a constant attached to your x expression, you'll take the reciprocal of that constant and attach it to the integral expression. And since you already had a 1 by 4 expression over here, we'll not miss that expression. We'll also attach the 1 by 4 expression over here. And now since you also got rid of all the indefinite integrals over here, you'll add the constant of integration at the last. So again, your final answer in this case would be minus x cos 2x by 4 plus sine 2x by 8 plus the constant of integration over here. So this would be your final answer to the integral of x sine x cos x in this case. And again, if you still didn't get this part, I would highly suggest you to first use substitution and assume your u function to be simply 2x and then solve for this integral over here, which you'll definitely get as this expression over here. So that's it for this video. Again, the main takeaway from this video is that whenever you have to solve indefinite or definite integrals, when you have a combination of functions, you basically have to identify the pattern and then use the most favorable methods of integration in order to solve for that patterns in these type of questions. So again, since in this question we saw a pattern of sin x and cos x being together, that gave us an idea that we can simply use the sin 2x property in order to simplify our indefinite integral. And then when we use that property and got this expression over here, we saw a combination of two functions which gave us a hint to solve this indefinite integral using integration by parts. So this was one approach in order to solve this indefinite integral over here. If you want to know a second approach, which is a bit more complex, you can simply use integration by parts over here. You can simply assume your first function to be x, and then your second function would be sin x cos x, and then you'll use the same formula of integration by parts to solve for this indefinite integral over here. But again, that approach will be a bit more complex than what we followed in this video to solve this indefinite integral over here. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.